All right, so we're going to start, and we have to start where I start every year. We have to find a place where everybody knows what I'm talking about. So we're going to start with a word you've known forever, and that's relations. And relations is a 7th grade vocabulary word, and it is just a set of ordered pairs. And since it's a set, you have to use the fancy bracket to indicate that it's a set, and then it's ordered pairs. So I have a parenthesis, so we have a set and they're ordered pairs. The parentheses indicate the ordered pair, and we have an X and a Y. And we have 4 different ways of representing a relation. We can have a table, a mapping, a graph, and an equation. So for this set of ordered pairs, if I use this table, first of all, are these sequential? Because what's missing? It goes from 0 to 2, correct? So I'm missing the 1. Also, then, if I want to move from the table to the mapping, this is your X and this is your Y. And we list our X's in smallest to greatest for the Y. So 0, 2, 3, and 4, and 1, 5, 7, and 9. And then we map them, which means we match the X to the Y. So this X goes here. And if I was going to graph this set of ordered pairs, this is the X and this is the Y. So if this is a defined set of ordered pairs, do I connect those dots? Yes? Why? You don't know, you're just guessing? Okay, why? Is it? You're giving up already? Is it a function? Why? I haven't connected the dots yet, so it's not passing any vertical line test. I'm not connecting them because they're... So this relation is a set of ordered pairs, okay? It is a set of ordered pairs, and we don't connect them unless I specifically say it's a line. And we haven't specifically said this is a line. And so part of what we'll do in pre-cal is we'll learn how to differentiate stuff like this. First of all, you said it was a function, but you said the vertical line test. It is a function, but not because of the vertical line test. Why is this a function? Thank you. The x's do not repeat, so I know it is a function. The x's don't repeat, so it's a function. So if I look at this, if I had to come up with the pattern to generate my y's, if you just take a look, what do you think it might be? What's the pattern that would come up with the equation? I'll give candy to anybody who can get it. 2x plus 1, you get candy. Hey, weren't you the same one that came up with the function too? Yeah. Woo. All right. Okay. Isn't that ironic? I'm giving dum-dums, but you were smart. You're smart. So, okay. So the domain is going to be the set of x's, and the range is going to be the set of y's. The domain is always the independent, and the range is always the dependent. So again, when I list ordered pairs, I'm not connecting the dots. This is discrete. I didn't list negative 1.5 and negative 1.5. So I only listed these, and so they're discrete. So if I list the domain, we're going to list smallest to biggest. And if they repeat, we don't use the repeaters, right? Only one time. So here I would do negative 5. Okay, what do I do with the next one? Where do I get the x's and y's? From the points, right? They're all listed. You could list the points so you could get the x's and y's. Now, Cabela, is that one, does that pass the vertical line test? Why? It doesn't. You're right. These two right here, same vertical line, so it doesn't pass. How about this one? Is this a function? The third one. Okay, who says? Okay, thumbs up for yes. Thumbs down for no. Some of you changed. Somebody said no. I heard it. Did you say no? I know who your Algebra 2 teacher was last year. Okay, look. Did the x's repeat? Who said yes? This 2 goes to 4. This negative 1 goes to 1. This 0 goes to 0. This 1 goes to 1. This 2 goes to 4. Every x goes to 1 y. So this is a function. Okay. So now I'm going to do continuous functions, and this is what we do most of the time, right? Most of the time we don't do the discrete ones, we do the continuous. So domain, left to right, left to right. If I looked at the left side, what's on the left side? It's an arrow, and that tells me that it's what? Negative infinity. On the right side, infinity. Now, let me back up for a second. We have 3 ways we can do this. We can do inequality. So that gives us the inequality. That's what inequality looks like. We can do set notation. And we can do interval notation. So if it has a line under it or it's closed, it gets a bracket. If it doesn't have a line under it, it's open and it gets a circle. Which way which way is the easiest to write it? Interval. Which way do you like to write it the best? Interval by far, right? It's just easier to write. And that's what we're going to do all the time in here, okay? So on some of your standardized tests, on some SAT tests, sometimes they throw in inequality, but we're going to write interval because on most of it, you'll see the interval. Okay, so the infinities always get parentheses, right, because they don't end. Okay, so the range is bottom to top. Bottom to top. So what's at the bottom? Arrows. And it's negative infinity because it's pointing down. At the top, 6. And is that a parenthesis or a bracket there? Correct. It's a bracket. Because that gets included in the solution set. Domain, left to right. So where does this start? Is that negative 3? To infinity, and then bottom to top. Okay, so for the next one, what do I write here? Left to right. So I go along, and I'm fine. And what happens right here? Are they connected? Why? There's a drop off, but what goes here? The asymptote goes there, right? Are you going to touch an asymptote? No, you're not. So if I go from here to here, I have to stop at the asymptote. So I'm going to get negative infinity to, is that at 3? 3, and then 3 to infinity. And what happens bottom to top? Bottom to top. Are they connected? No, because this is here, and that is at what? Oh, so I'm going to have negative infinity to 0, 0 to infinity. And this is a picture of the rational function. This is a rational parent function. This is like the line that gets blown in half because of the asymptotes. Okay. How about number 7? Left to right. How far? Does it keep going? These are, yeah, we're going to call these are arrows. Left to right. So does it stop? Have you ever seen this before? How many of you took physics? It is. It is. So you kind of covered these in physics. This is something we're going to learn in pre-cal. So we're going to see the wavy curves in here. All right. So this one keeps going. So domain is negative infinity to infinity. But bottom, what's on the bottom? Because what's going to happen here? That goes back up, right? Does it ever get any lower than here? Does it ever get any higher than here? No. So here to here. Are those 5s? Yeah? So do we include them or we don't include them? Open or closed? There's no open circles, so you include them. Top to bottom. Is this a function? Passes the vertical line test, so it is a function. How about this one? Function, no function. Function, it passes the vertical line test. What is that little thing there? What does that mean? It's not included. So if it's not included, this point, -1, -3, that point is not included, so it can't be in your domain and range. So when I write this, number 9, function or no function? No function, that fails the vertical line test, right? Touches in 2 places. If I sat that up, what kind of function do I have? Was the absolute value function when it's a v, right? So this is the v that laid down. Okay, so the domain, left to right. Left is -infinity, and where does it stop? At 0, bless you. Bottom to top. -infinity to infinity. Okay, you all try the next 3. Okay, so check your answers. All right, double check. So, for which one, baby? Okay, so the domain, if you start on the left, what's on the left? -infinity, and where's the asymptote? Okay, so we start on the left, and we run into the asymptote, and the asymptote's at -1. So we're not going to touch -1. We're going to get really, really close, but not touch it. And then we're going to go -1 to infinity on the other side to finish it off. So, number 11, while we're on that one, so this one, the domain had a break at -1. Why does the range not have a break? If I start at the bottom and I go, are there any numbers not included? No. There's no break on bottom to top, right? The break happens this way. So that's why we have this and not here. All right, the last one over here, number 12, the question I want to ask is here, the -4 does not get included. When I do the range, bottom to top, why is there no break with this? The bottom point is included, but I'm going up, and this is a not included point. So why didn't I break here? Right? So if I'm going up, there's a break on this side, right? But what about this side? Is there a break there? So that point gets included. So that's why there's no break going up and down. Does that make sense? You be quiet. Anybody other than Cabela have a question? All right. All right, so a function is a special type of relation in which each element of the domain is paired with exactly one element of the range. So look at number 13. We've already talked about this. If the x's don't repeat, it's a function. Do any of the x's repeat? This is yes. Number 14. Do any of the x's repeat? Yes. The 9 right here, it goes to 2 elements, so this is a no. Do the x's repeat? So this is a yes. So the vertical line test. Does this pass? Yes. And this is the absolute value function, and it's reflected over the x-axis. Does this pass? No. This is a no. This is a parabola that's laid down, and this is, and it's never a function. We just talked about this one. It's a rational function, and it has 2 asymptotes. But does it pass the vertical line test? It does.